Trigonometric double angles part 2. Let's start using the formulae which we dealt with in the last video. This is going to be pretty straightforward. Note that a double angle is always more complex than a single angle. So if you have a 2 theta and a theta, the 2 theta is the more complex angle. So this could help you choosing which side to start with in an identity as well. The side with the 2 theta or the 2x or the 2a, 2b is the one more likely that is going to be best to start with. Even if you have theta and then you have a half theta, then the theta is the more complex because you need to use a double angle to get it down to half theta. So there we are. Double angle is always considered more complex than a single angle. Now sine 2 theta, pretty straightforward. There's only one expansion for sine of 2 theta, and that is that one there. So we expand it, and it simplifies to cos. Let's have a look at another one. Now we've had a lot of these before, but let's do it once more. Multiply out, square first, multiply double, square last. There we are. I hope you can remember why these are in blue. It's your Pythagorean identity. So there we have the left-hand side equal to the right-hand side. Now we need to simplify sine 2 alpha plus 1 over sine alpha plus cos alpha. Now that reminds us then, because sine alpha plus cos alpha cannot be simplified, we need the top to have a sine alpha plus cos alpha if we're going to be able to do any cancelling or anything. So if we look at sine 2 alpha, well, that's 2 sine alpha cos alpha, and it's related directly to the previous question. If we have a look at that, we can now go the other way and write 1 as sine squared plus cos squared. There we are. Sine 2 alpha, 2 sine alpha cos alpha, sine squared plus cos squared gives you your 1. Now we're going for algebra here. This one here factorizes. There we are, sine alpha plus cos alpha all squared, and we can reduce. There we are. Here's a similar one. Now it's sine alpha minus cos alpha all squared. So we're going to go through the same pattern. Square the top, write sine 2 alpha as sine 2 theta as 2 sine theta cos theta. Our blues are going to become 1, and we can cancel. Now, this is pretty straightforward. The only thing we can simplify in that whole expression is the double angle, and there is the formula. So we do that. Now it's algebra time. Common factor of sine b we take out, and you notice that we have a 2 cos b minus 1 factor top and bottom. Goodbye. Note, when expanding cos 2 theta, there are 3 options. Remember, we've already dealt with that previously. There are 3 options, and we need to make a decision as to which one to use, or we could end up going all the way around a long path. So let's have a look at this one. Cos 2 theta. Picture putting cos squared minus sine squared on top. Does it have potential? Picture putting 2 cos squared minus 1 on top. Picture putting 1 minus 2 cos squared on top. Now my guideline is that there's a cos and a sine which cannot be simplified on the bottom. So I'm likely to take the first one, which has coses and sines. Now the top line has an algebraic step. Hope you've noticed. Difference of squares. And there's cos theta minus sine theta, numerator and denominator. There we are. Next one. Now we need to make a decision again. 1 plus cos 2m all over 1 minus m squared. I remember that 1 minus m squared. I hope you can remember it too. That rings a bell. That's cos squared from your Pythagorean identity. So that may be quite useful. Let's just keep it in mind. Now, 1 plus cos 2m, we have the 3 options. Very useful to get rid of the 1. It would really be useful to get rid of the 1. So, if you have a look, you need to say, well, it's plus cos 2m, so where's there a cos double angle which has a negative 1? There we are. There we are. Because now we end up with 2 cos squared m on the top line. Bottom line goes to cos squared m, and we end up with just 2. Don't you love these? Next one. Now, if you have a look at the top line, we have an extra cos x attached on there. Now we need to think about that. With an extra cos x on there, which of these would be best? We need to factorize it. So which of those gives the best options? There we are. There's your top line with the 3 possible options. That one there is going nowhere. Cos squared minus sine squared plus cos. You cannot factorize that. That one is going nowhere. 1 minus 2 sine squared plus cos. This one can go somewhere because this is a quadratic trinomial. Cos squared, cos, constant. So there we are. We're going to use that one. So let's have a look. There we are. We've slotted in cos 2x. We've slotted in 2 cos squared x minus 1. Which in fact, if I reorder it, is a useful quadratic equation, cos squared, cos constant. And it factorizes into 2 brackets. Let's hope your quadratics are up to scratch. Bottom line, well, I need to reduce that cos to sine 2x. There's only one option. So therefore, we put it in there. Now we have the algebraic step. I hope you notice. There's a common sign. And top and bottom, we have a common factor of 2 cos x minus 1. It's gone. Well, let's have a look again. We have cos 2a, so straight away the decision comes up again. Which one? Which one? I'm going straight for the one that has a plus 1 in it because I've got a minus cos 2 alpha because that'll get rid of the 1. But have a look. 1 minus cos squared minus sine, plus sine squared, that won't factorize. 1 minus 2 cos squared alpha minus 1 would give you 1 minus 2 cos squared plus 1, which will give you 2 minus 2 cos squared, which has potential, and you will get somewhere with it, but this is by far the most straightforward. Have a look here. 1 minus 1 is 0, and you're going to end up with just a plus 2 sine squared. So let's go for that one. Bottom line, bottom one, the denominator is pretty straightforward. Once again, we only have one option, but we must reduce. So there we are, taking away the brackets. Top line simplifies. Bottom line, we've expanded the sine 2 alpha, and we can reduce algebraically. Let's try some now. Here we are. Now what you need to do is pause and try them out. The answers are going to appear now. So pause if you're going to try them. Let's look at the first one. Cos 2 alpha, cos 2 theta, cos theta minus sine squared. Below we need both cos squared and sine squared. There we are. Difference of squares on the top line. Algebraic reduction. Cancelling. This one, you should be groaning by now seeing this one. You've seen it so often. Square out the top line. Bottom line, expand the sine 2 theta. I haven't given you a hint this time because surely at this stage you shouldn't need the blues to see that sine squared plus cos squared is 1. And numerator, denominator are identical. This one, we're going to need to get rid of the 1 on the top to make life easier. So we're going to select the expansion that has the -1. There it is there. So there we are. Bottom line, 1 minus sine squared is cos squared. There we are. 2. Next one. We're going to do a similar thing. I want to get rid of that 1 and it's minus cos 2 alpha, so I want the expansion that has a +1 in it. There we are there. So we use that expansion on the top, we use the normal sine expansion on the bottom. Top line simplifies to 2 sine squared alpha, down to sine alpha over cos alpha, which you're used to by now, tan alpha. Next one. Top line, no question what to do. Bottom line, we can do nothing. Sine expansion. Now we're into algebra. Factorize. Common factor. 2 cos b minus 1 is a factor on the top and on the bottom. Therefore we have sine b. Last one of this set. We have a cos and a cos 2x. That's going to tell you something. Hope you remember from the examples. We're going to have to use the one that only has cos squareds, so we can end up with a quadratic trinomial. Here we are. I've expanded sine 2x to 2 sine x cos x. Top line factorizes to 2 brackets as a quadratic trinomial. Bottom line, common factor, sine x. There we have a 2 cos x minus 1 common to the numerator and the denominator. Cos x plus 1 over sine x. Final answer. Let's go to further manipulations of double angles. We could have such fun with these, I'm sure you'll agree. Far better than playing PlayStation or something like that. There we are. Write sine 4x in terms of sine and or cos x. Well, there is no expansion for sine of 4x. Please don't try to do anything and assume that there is something for that. There is not. The only thing we can do with sine 4x is to write it as sine of twice 2x. Now we can use our double angle formula, twice 2x, so we're going to have a 2x there and a 2x there. There we are. Now we can expand. Sine 2x, no question. We're going to go again with that formula. Cos 2x, well, this is thumb suck. You can decide. If you've been told to prove sine 4x equal to some expression, then that would determine what you're going to use here. You could do a bit of inspection and see, but in this case, anything. So I'll sit on the fence. I'll use cos squared minus sine squared. Multiply out, there's our answer. Cos 2x in terms of sine x. Now, this comes up a lot, except the other way, sine x in terms of cos 2x, when you're at university. Because when you're in integral calculus, you need to be able to do this sort of manipulation. Well, Well, really sine squared and cos 2x, I guess. But anyway, I'm rambling. Cos 2x in terms of sine x. So if we look and say, well, which of all these has a cos 2x and a sine x? There you are. Alright, it's a sine squared, but that's fine. We have a thing called square root. There we are. So I'm going to write cos 2x equals 1 minus 2 sine squared x. Now what I'm going to do, trigonometry finished, I'm going to solve that algebraic equation. I'm going to take 2 sine squared to that side because that makes it positive. There we are. I'm actually jumping the gun. I should have waited till it said this. There we are. Now, next question says, hence find sine x in terms of cos 2x. Well, we have sine squared. So to get rid of the square, we square root. Don't forget the plus or minus. There we are. Cos x in terms of cos half x. Have a thought. Which is the most complex of those two? The answer is that it's cos x, because x is the double angle. So we're going to write cos of x as cos of twice half x. Cos of twice half x, and then I'm going to use that expansion because it says in terms of half x, cos. Hence find cos squared half x in terms of cos x. Well, we're just going to solve it. There we are, cos squared half x. 1 plus cos x over 2. Next, find cos half x in terms of cos x. Well, once again, we have a squared. We want to get rid of it. Square root with a plus or minus. Now that plus or minus doesn't necessarily happen all the time. It means you must choose whether it's going to have a positive or a negative, because it can have either. Right, slightly different tack. This is one of those where you have your x, y, r. There we are. We've been given x over r. Now remember, that doesn't mean that x is 3 and r is 5. It could be 6, 10. But we'll say let x equal 3, r equal 5. Thanks, Pythagoras. Pretty easy from here. 3, 4, 5 triangle. Y is 4. Positive because theta is acute. Always keep that in mind. Now we're going to find the value of sine 2 theta. So the first thing we'll do is expand sine 2 theta. Now it should be pretty straightforward from here. Y over r, x over r. There we are. 24 over 25. Cos 2p equals 1/3. P acute. Find sine p. Well, once again we say, well, where do we have cos 2p and sine p? Sine theta, cos 2 theta. So therefore, if cos 2p equals 1/3, it means 1 minus 2 sine squared p is 1/3. Now it's algebra. Here I've taken the 2 sine squared across to the other side to make it positive. On the left it's going to become 2/3. I'm going to write the equation the other way around. Divide by 2. And now we square root. P acute, so when we square root, we don't worry about a plus or minus. There we are. Some may write that after that as root 3 over 3 because that's considered more simpler than 1 over root 3. Here we are, exercise time. What you need to do is pause and try these exercises. Pause and try these exercises. Answers to follow. Let's do the exercises now. Right. Some of these are pretty straightforward. Sine 2a in terms of a, well, there we are, straight off. Sine 6b in terms of 3b, well, it just means that's the double of that, so we're going to go the same way. 2 sine 3b cos 3b. 1 minus cos 2x in terms of x. Well, we have 3 options open to us there. We could write that one, or that one. But I want to be mathematically neat, so which one am I going to use? Well, have a look. 1 minus cos, so I want this to have a 1 in it, a plus 1. So therefore, I'm going to use the third one, and that simplifies to 2 sine squared x. Cos 2a in terms of a. Toughy, hey? Well, we have 3 of them. There we are, we write all 3 down. Sine a plus cos a all squared in terms of 2a. Well, let's multiply it out first. Oh, gee, I've gone straight there. And I'll tell you why I've gone straight there, because we've done it so often. When you multiply out sine squared plus 2 sine cos plus cos squared. Our sine squared plus cos squared gives you the 1. Our 2 sine cos gives you the double angle. 2 sine squared x in terms of 2x. So I need to say, well, which formula has a 2x and an x with sine? 2x and an x. 2 theta and a theta with sine. There we are. So therefore, I'm going to write cos 2x equals 1 minus 2 sine squared x. Now I'm going to solve that for 2 sine squared x. There we are. 2 sine squared x across, cos 2x to that side. This now has given 2 sine squared x in terms of a 2x. Cos squared x in terms of 2x, well, let's have a look. Cos squared x in terms of 2x, where do we have a cos squared x and a 2x? There's our cos squared, there's our 2x. So we're going to use the cos squared, 2 cos squared minus 1 expansion for cos 2x. That's equal to cos 2x. And I'm going to solve that for cos squared x. There we are. Cos 4a in terms of a. Now remember, we do not have a formula. Please don't say cos 4a is cos to the 4a minus sine to the 4a. No, no, no. We only have a double angle formula. So we have to see this as a double angle. Therefore, we're going to see it as twice 2a. Now, the double angle formula, I've used that one from there. 1 minus 2 sine squared 2a. Now I'm going to take sine 2a, and I'm going to say, well, sine 2a will be 2 sine a cos a. There we are. Notice sine squared 2a means the sine of 2a all squared. So therefore sine 2a, 2 sine a cos a, all squared. Multiply it out, and there it is. Or, instead of using 1 minus 2 sine squared a, I could have used 2 cos squared 2a minus 1. And then done an expansion that way. Or dot, dot, dot. I mean, you could keep doing these for the next hour with the different variations on a theme. Right, let's have a look at some more simplification. First thing I'm going to do is common denominator. Notice what I've done is I've multiplied top by cos 2x, bottom by cos 2x. So cos 2x times that gives you 1. Cos 2x times that gives you cos 2x. Cos 2x times that gives you your 1. Cos 2x times that gives you your cos 2x. The other way to do it is write this as 1 minus cos 2x all over cos 2x. 1 plus cos 2x all over cos 2x, and then multiply by the inverses. Your cos 2x's will cancel. You'll end up with this again. Now, the only way to simplify is if I can get it either to factorizable expressions, which will then cancel. But this is easy because I can get rid of the 1, get rid of the 1. Use the one that has a plus 1, use the one that has a minus 1. There we are. And that simplifies to that. 2's cancel, and sine squared over cos squared, tan squared. Next one, same sort of thing. Cos 2a, I'm going to get rid of the 1. I'm going to use the one that has a minus 1. There we are. Expand the top, only one option. Cancel 2 and cos a, and that of course is tan a. Same thing now. 1 minus cos 2b. I'm going to look for the one with a plus. There it is, plus 1. There we are. 1 over tan b plus tan b times sine of 2b. Well, that's sine over cos. Now, where did this come from? Well, what I've done is 1 over sine over cos, which means you multiply by cos over sine. So therefore, it just flips it. This is the inverse of sine. Of tan, sorry, inverse of tan. Now, if tan is sine over cos, the inverse will be cos over sine. There's my expansion there. Multiplying out, there we are. And have a look. If I take out a common 2, I've got cos squared plus sine squared. Sine A equals 3/5. A lies between 90 and 180. Keep that in mind. That means second, third, fourth quadrants. Determine the following by means of a diagram. Right. I'll be naughty. I don't have my diagram here, but you should show a second quadrant angle. Angle A going around to the second quadrant angle and label the different points. There we are. 3/5 y over r. 4 by Pythagoras theorem, and because sine is positive and it's second, third, or fourth quadrants, it must be 1, 2, 2, 3, 4, it must be 2 where tan x is negative. Now we're going to find sine of 2a. So there we are. Expand sine of 2a. 2 sine a cos a. Substitute your values in y over r, x over r, and there's our answer. Now this cos 2a, you could make life easy for yourself, or you could get more complex. The easiest way to go is to say, well, I already know sine of a, so why don't I just expand that with the sine of a formula? There we are. Cos 2a equals 1 minus 2 sine squared a. Now I know sine is 3/5, so therefore 1 minus twice 3/5 squared simplifies to 7 over 25. Cos 2a equals 1/8, find cos a. What I'm going to do with this one is I'm just going to, instead of this, I'm going to write the formula there and solve it for cos. Don't have to go x, y, r. The x, y, r of 2a are not related to the x, y, r of a, so don't even think about going that way. They are not related. They're totally different. So there we are. 2 cos squared a minus 1 equals 1/8. Notice I have to find cos. So I said, well, there's, instead of cos 2, why don't I write 2 cos squared minus 1? Now I already have an equation just in A, so I'm going to solve it. I added 1 to the other side, divided by 2, square root both sides, there we are. Plus or minus, we are not sure about quadrants. We must have the plus or minus. Number 5. There we have a right angled triangle, C is 90 degrees. D is a point on AC, such that AD is x units, DC is 3 units. B and D are joined so that it bisects this angle. BC is 4 units. Calculate the value of x. Now the whole idea here is that we have two variables. We have theta and we have x. So we need simultaneous equations because we have theta and we have x. So one simultaneous equation can involve 2 theta and the other can involve a 2 theta and x, and the other one can involve theta with a substitution. Right, tan theta is 3 over 4. There we are. So we now are x, y, r. Now we've got that from this equation that tan theta equals 3 over 4. So we now have x, y, r. So in fact we can now forget about the theta. We can now go for tan of 2 theta is x plus 3 over 4, which is sine 2 theta over cos 2 theta is x plus 3 over 4. We're now going to expand those two. 2 sine theta cos theta over 2 cos squared theta minus 1. I'm going to put y over r, x over r, x over r. Simplifies to 24 over 7. Solve for x. Notice again that if we're trying to find the x, just for your thought process, we're going to have to involve 2 theta. X plus 3 over 4 is 2 theta, so I say, well, I've got to do something to find theta. That's why I come to this triangle here to find something about theta. Cos 2a 7/25. Determine the value of cos a. Well, remember, don't use x by r. X by r of 2a bear no resemblance to x by r of a and have no relationship with them directly. So all I do is I'll say, well, instead of, here's that equation. Why don't I expand this instead of 2a to a cos of a and solve. So there we are. 2 cos squared a minus 1 from there equals 7/25. Added the 1 to the other side. Divided by 2. Square root the plus or minus. This one's the same sort of thing. It says determine sine x, so the only difference is I'm going to use the sine expansion for cos 2x. I'm going to solve for sine. 2 sine squared equals 1 plus 1/9, which is 10 over 9. Divide by 2, 5 over 9, plus or minus square root to find sine of a. Cos 2y, 17 over 25, sine of y. Same thing again. There we are, 1 minus 2 sine squared. Solve for sine squared. Square root both sides with a plus or minus. There we are. This one's actually quite a straightforward one. I mean, you've been told 2 sine cos, 2 sine alpha cos alpha is 7/9, and you've been told sine alpha is 2/3. So where you think 2 sine alpha cos alpha is 7/9, you know the sine alpha. So therefore I'm going to write 2 sine alpha cos alpha is 7/9. Now I know sine is 2/3. There we are. Solve for cos of alpha. And there's our solution.